Hey York Explorers, Mr. Ord here. Today is day number 2 for comparing fractions, and we're going to be specifically looking at strategies for comparing fractions. The first one we should actually be pretty familiar with. It's using the benchmark 1/2. And we're going to be using 2/6 and 5/8 to help us out with this. I've got the rectangles already set up to model these fractions. So I'm going to use this one right here. This is split up into 6. So this is 2/6 is what I need to show. Here's 1 and 2. We're going to come down to this next one. This one's split up into 8s, and I'm going to shade in 5 out of 8. So there's 1, 2, 3, 4, and 5. Okay, and now you're going to notice this red line that's right here. That is actually showing us where 1/2 is at. So if we wanted an equivalent fraction in 6 to equal 1/2, we would need 3/6. We need 3 out of 6 shaded. To get an equivalent fraction in 8s for 1/2, we would need 4 out of 8 shaded. Okay, and here's where the benchmark 1/2 once again comes in and helps us out quite a bit. So looking at this, I know, okay, if I need an equivalent fraction to 1/2, I know that I need 3/6. I need 3 of these shaded. Well, we only have 2/6, and 2 out of 6 is less than 1/2. Now if we come down here, this one, 5/8, well, we only need 4/8, but we have 5/8. That's past 1/2. It's actually bigger than 1/2. So if we think in terms of 1/2, 2/6 is less than 1/2. 5/8 is bigger than 1/2. Because of that, that tells us that 5/8 is bigger than 2/6. And there's other strategies for comparing fractions because the benchmark 1/2 may not always work. I mean, if two fractions are if both of them are greater than 1/2, well, it's a little bit harder to use the benchmark 1/2. Or if they're both less than 1/2, it can be harder. That's why we have other strategies. And now we're going to take a look at that second strategy. All right, let's take a look at this second strategy. Now, if the two fractions have the same denominator, that means the same bottom number, then you're going to look at the numerator. Numerator is the top number. The more parts, the bigger the fraction. So we're going to look at 4/6 and 2/6. Right away, they have the same denominator. That means we can go right up top and look at the numerator, and whichever top number is bigger, that means that fraction is bigger. And so let's take a look at this with the models. These are both have 6 total parts. So I'm going to first model 4/6. So I'm going to shade in 4. 1, 2, 3, 4. Now we're going to model 2/6. 1, 2. They have the same denominator. That means we have 6 pieces here, 6 pieces here. And now we can go, oh, 4 parts is bigger than 2 parts. And that tells us that 4/6 is bigger than 2/6. All right, now we're going to look at our third and final strategy. All right, I'm going to scoot this up so that we can take a look at the third and final strategy. And the third one is if the two fractions that you're comparing have the same numerator. That means the top number is the same. If that happens, you're going to look at the denominator. The bigger the denominator, the smaller the fraction. Let me say this one again. If your two fractions have the same numerator, that means the top numbers are the same. Then you're going to actually look at the bottom number, or the denominator. The bigger the denominator, the smaller the fraction. All right, so 2/3 and 2/8. If we're comparing these over here, I have the models already set up for us. So let's show 2/3. Here's 3 pieces. Shade in 1, 2. And then this right here, 2 8s. Here's 8 pieces down here. 1 and 2, and ooh, we can see that 2/3 is way, way bigger than 2 8s. We're going to come back up to this though. The bigger the denominator, the smaller the fraction. So the numerators are the same. And the bigger the denominator, the smaller the fraction. So if we look at 2/3 and 2 8s, having 2 pieces out of 3 is way bigger than just having 2 out of 8 pieces. Can you imagine if this was 2 out of 100 pieces? It'd be way over here. 2/3 would be way bigger. So that's why this says the bigger the denominator, the smaller the fraction. So if the numerators are the same, look at the denominators. Whichever one is smallest is biggest. Now, of course, if the benchmark 1/2 or the same denominator, or even they don't have the same numerator, you can use these models just like I was doing to kind of show. But the other thing that you can use besides drawing out the models is using the fraction wall that we've been using as well. And all right, I'm going to show you what you're going to be working on today.
Okay, so when you open up the assignment, May 4th, comparing fractions assignment, this is what it'll look like. Let's kind of go through the directions together. Select the symbol that correctly compares the fractions. Use the strategies for comparing fractions anchor chart to help you. That's what we just did in the lesson. So if you click on this, it's should open up a new tab. And it'll be this that we just did. Next thing, so if you get stuck, use the fraction tiles here. So if none of the strategies seem to be working for you, use the fraction wall tiles. Alright, so let's do this kind of first one together. Which symbol correctly compares the fractions below? Okay, we got 1/2 and 8/12. Okay, so quickly, if we looked here, use the benchmark 1/2. So if we use that 1/2, okay, 8/12. So we got 1/2, we got 8/12. We only need 6/12 to equal 1/2. We have 8/12. That's bigger than 1/2. So we'd select this symbol. The bigger number, the alligator eats the bigger number. One way just to show, to model that real quick, we have 1/2 and we had 8/12. If you really got stuck, there's 4, 5, 6, 7, 8 again right here. Cut right down. 8/12 is bigger. Alright, if you get stuck, reach out to your teacher for help.